It has come to my attention that some of you might not understand the binary. It has come to my attention that some of you might not understand the binary system. The binary system is the computer's way of understanding what you key into it, the data that you key into it, or the data that it's reading. It's a base 2 system. It's basically zeros and ones. The presence of a zero means the absence of electrical current, and the presence of a one means the presence of an electrical current. So you have a series of zeros and ones that determine a character. For example, 8 bits will make a byte. So 8 zeros and ones makes 1 byte. 1 byte is a character, like the letter A or the letter B, or a special character like the pound sign or the asterisk. Okay, so a series of zeros and ones will determine which letter of the alphabet will be displayed on your screen once you key in a number or a letter or a character. The other thing I want to talk about is the binary conversions. Okay, we go from 1 through 128. It's a base 2 system, again. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. And 64 times 2 is 128. Okay, so what I'm going to do is convert a decimal number to a binary number. Okay, say we have the number 3. How do we convert that to binary numbers? Can we use a 1? Yes. So we use 1. Can we use a 2? Yes. So we have 2. The rest would be zeros. So that's the binary number for 3, because you can use those two numbers. You just have to add up the numbers as you go along. Okay, let's make it a little more difficult. Say we need 10, all right? We want to take 10 and convert it to binary. Can we use 1? No. Can we use 2? Yes. Can we use 4? No. Can we use 8? Yes. The rest would be zeros. Okay, so that's the number 10. 8 plus 2 is 10, just like that. The next thing I want to show you how to do is convert from binary to decimal. Okay, suppose we have the binary number 1, 0, 0, 0, 0, 0, 1, and then 0. What would be the decimal equivalent be? That would be 128 plus 2. That gives you 130. So that's how simple binary conversion is. Converting from binary to decimal and from decimal to binary. I want to show you how to use Excel to interpret binary and decimal and convert binary to decimal and binary to hexadecimal, or hexadecimal to decimal. All right, so here we have a decimal number, 20. And we want to know what would 20 be in hexadecimal. So we go equal DEC, and automatically Excel is smart enough to know what you're trying to do, so you can choose one of them. Hexadecimal, choose the location of the cell, and you hit enter. So this would be the hexadecimal equivalent. $14. Now say I wanted the binary equivalent. So I would go equal binary, decimal to binary. Decimal to binary. Pick the number I want to change. That is your binary equivalent. 20 would be 10100. Now, suppose I wanted to change my decimal number into my binary number to a decimal, to my hexadecimal. So I would go here and go decimal. Okay, so I want my binary to be hexadecimal, to decimal. Okay, so I go equal, and then I go BIN, choose the location. Oops. Let's do this again. So this gives you any binary number that you have, you can see what the decimal equivalent is. I hope this helps. Bye-bye.